Are you working on a plastic part that needs strength, heat resistance or durability? Then nylon, also known as PA or polyamide, is a material you need to understand. Hey everyone, welcome to UG Mold Tech. Today we are diving into one of the most widely used engineering plastics in the world, nylon, also known as PA or polyamide. You've probably used it, worn it or maybe even molded it without realizing how powerful and versatile it really is. So what exactly is PA or polyamide? To put it simply, is the scientific name for nylon. The introduction of nylon revolutionized the textile industry, particularly with the production of nylon stockings. The name nylon was derived from the combination of New York and London. Nylon is a family of synthetic polymers, a groundbreaking material first developed in the 1930s, which quickly gained popularity as alternative to silk stockings. It was originally conceived and used as a silk substitute. That's right, primarily for stockings. This was revolutionary at the time, providing an affordable and durable alternative to silk. But today, nylon's versatility shines through, playing a much bigger role in a diverse range of applications, from automotive parts requiring robust performance to intricate mechanical gears demanding precision, to the vast world of textiles and even the cutting-edge field of 3D printing, where it enables the creation of complex and functional prototypes. The term polyamide refers to the repeating amide linkages in the molecular chain. These linkages are the key to nylon's exceptional properties. This unique structure gives nylon its inherent strength, allowing it to withstand significant stress and strain. It also contributes to its flexibility, enabling it to bend and deform without breaking. And finally, it provides resistance to wear, ensuring longevity and durability in demanding applications. There are several types of nylon, each with its own unique characteristics and properties, but two of the most common and widely used are PA6 and PA66. These two variants represent a significant portion of the nylon market and are employed in a vast array of applications. PA6. This type is made by ring-opening polymerization of caprolactam, a process that results in a polymer with excellent properties. It's known for being tough, able to withstand significant impact without fracturing. It's also impact resistant, meaning it can absorb energy from sudden forces. This makes it a great choice for automotive components, various consumer goods, and even packaging solutions. PA66. This variant is made from hexamethylene diamine and adipic acid, resulting in a slightly different molecular structure and enhanced performance characteristics. It's generally stronger than PA6, exhibiting higher tensile strength and resistance to deformation. It's also stiffer, maintaining its shape under load. And perhaps most importantly, it's more heat resistant, capable of withstanding higher temperatures without degrading. This makes it perfect for demanding mechanical components used in various industrial machinery. So if you are designing a gear or a part that needs precision and durability, where dimensional stability and resistance to high temperatures are critical, PA66 might be your go-to material. Its superior strength and heat resistance make it ideal for demanding applications. However, if you need a flexible, more affordable option where impact resistance and cost effectiveness are paramount, PA6 is often the better choice. Ultimately, the selection depends on the specific requirements of your project. Let's break down the key properties that make nylon a superstar in the world of engineering plastics. We'll explore why engineers and designers consistently choose nylon for a wide array of applications, from the mundane to the mission critical. Understanding these properties is crucial for anyone working with or specifying plastic materials. First up, high mechanical strength. Nylon's robust molecular structure gives it exceptional tensile and compressive strength, making it great for load-bearing parts that need to withstand significant forces without deforming or breaking. Next, we have excellent wear resistance. Nylon's ability to withstand friction and abrasion makes it ideal for gears, bushings, and other components that experience constant rubbing or sliding. This translates to longer part life and reduced maintenance. Another key advantage is that it's self-lubricating. Nylon has a naturally low coefficient of friction, which reduces friction between moving parts without the need for external lubricants in many applications. Nylon also exhibits good thermal stability. It can handle moderate to high heat without significant degradation, making it suitable for applications where temperature fluctuations are a concern. Furthermore, nylon boasts impressive chemical resistance. It resists a wide range of chemicals, including oils, greases, and solvents, ensuring its integrity in harsh environments. And let's not forget that it's lightweight, much lighter than metal alternatives. This is a huge advantage in applications where weight reduction is critical, such as in the automotive and aerospace industries. And here's the bonus, but also something to be aware of. Nylon can absorb moisture from the air. This moisture absorption can actually improve its toughness and impact resistance, making it less brittle. However, it also affects its dimensions slightly, so designers need to account for that expansion and contraction in their designs. Nylon is most commonly processed using injection molding, one of the fastest and most efficient ways to mass produce complex plastic parts with high precision and repeatability. Here's how it works in a nutshell. Nylon pellets are fed into the injection molding machine, where they are heated, melted into a viscous liquid, and then injected under high pressure into a mold cavity. Once cooled and solidified, the mold opens automatically and the finished part is ejected. It's a remarkably fast, scalable, and precise manufacturing process, allowing for the production of intricate shapes and designs. You'll see molded nylon in everything from car engine covers, cable ties, and toothbrush bristles to even more demanding applications like wind turbine blades and medical devices, showcasing its versatility and widespread use. So, where do we actually see nylon making a difference in the real world? The applications are incredibly diverse, touching nearly every aspect of modern life. Let's explore some key areas where nylon's unique properties shine. Automotive gears, fuel lines, under the hood parts. From the engine compartment to the interior, nylon plays a crucial role in enhancing vehicle performance and reliability. Its resistance to heat, chemicals, and wear makes it ideal for demanding automotive environments. Electronics, connectors, housings. In the world of electronics, precision and durability are paramount. Nylon provides excellent insulation, strength, and dimensional stability, making it perfect for connectors, housings, and other critical components. It helps ensure reliable performance in everything from smartphones to industrial control systems, consumer goods, zippers, sportswear, tools, and even your toothbrush. Nylon's versatility extends to a wide array of consumer products. Its strength, flexibility, and resistance to abrasion make it ideal for zippers, apparel, and tool handles. Plus, it's lightweight and can be easily dyed in a variety of colors, making it a popular choice for designers. Industrial, machine parts, bushings, rollers, and cable ties. In industrial settings, nylon stands up to the toughest challenges. Its high strength, low friction, and resistance to wear make it perfect for machine parts, bushings, and rollers. Nylon cable ties are also essential for organizing and securing wires and cables in a variety of applications. 3D printing, especially in functional prototyping, nylon filament. Nylon filament is a popular choice for 3D printing functional prototypes and end-use parts. Its strength, durability, and resistance to heat and chemicals make it ideal for a wide range of applications. Engineers and designers use nylon to create everything from jigs and fixtures to gears and housings. This versatility makes nylon a go-to for both product design and functional manufacturing. From everyday consumer goods to critical industrial components, nylon's unique combination of properties makes it an indispensable material. Its adaptability allows engineers and designers to push the boundaries of innovation and create products that are stronger, lighter, and more durable. If you found this video helpful and informative, give it a thumbs up to show your support, share it with your friends who might also benefit from learning about nylon, and hit subscribe to stay updated on more engineering content. Got a burning question about nylon or another fascinating plastic material? Don't hesitate to drop it in the comments section below.